Alright, it was a bit of a tight squeeze, and it took a few kludges, but I managed to fit the whole thing onto one of these small boards. Now before I power it up and turn it on, I want to do some continuity tests just to make sure that nothing is obviously wrong with it. Alright, so this one here should be my plus 12, and that's on these corners. That's all good. This should be my minus 12 volts on these other corners. That's good. Now these two should not be shorted out to each other. That's good. Neither of them should be shorted to ground. That's good. The plus 5 and the ground should not be shorted together. There we go, that's good. And then there are a few places on the back that make me kind of nervous where I had to use heat shrink tubing. Let's make sure that those aren't connected where they shouldn't be. But everything looks okay. Now the first thing I want to do is put on just the 5 volt supply for the relays and make sure that I can actually switch the relays with 3.3 volts. I don't know if the clicking is gonna be audible, but they work. Also, one of these relays should short together these two terminals. Not that one. Yep, that does it. Alright, now I have all the power supplies hooked up, and I can do the smoke test with the op amps powered up. This is just a 555 timer putting out 1 kilohertz for some more tests later. But first of all, let's turn this on. And so far nothing's heating up or blowing up. That's good. Alright, now with both of the input terminals at ground, the outputs should be biased to about 2.5 volts. That's close enough, right? And then here's the current measurement output. Let's clip that on. It's biased at about the same, about 3 volts. Let's put it back on the voltage measurement. Now if I put a 5 volt difference on the two, okay, there we go, it's dropped down a bit. Now let's swap these, and that should go up a bit. Okay, so it is actually measuring voltage. That's good. Alright, now I'm looking at the output of the current measurement amplifier, and I have a 1 kilo ohm resistor over 5 volts on these two input terminals here, so I should get about 5 milliamps, which should show up as about a 0.5 volt change on the output. Now one of these relays turns on that current measurement path. I think it's this one. Yeah, there we go. That's about 0.3 volt change. That's close enough, right? Now let's switch this around. Now it should change in the other direction. There we go, 0.3 volts up. So it is measuring current. That's good enough. It's working. So now I have both of the input terminals just connected together, and then that is connected to the output of this little square wave generator. So all I'm doing now is just putting in a common mode square wave signal, and then I can watch the output on the oscilloscope and turn the knobs until it disappears. I have one of the scope channels on the output of the voltage measuring amp, and the other one just put right onto the output of the 555 timer. So the top channel here is the 555 timer, just the 1 kilohertz, and the bottom is the output of the voltage measurement. So the bottom trace, the output of the voltage measurement, looks really noisy. That's probably because I don't have any decoupling caps on this board. I'll need to put some decoupling caps on there to clean that up. But for now, let's see if we can adjust these common mode knobs. Looks like that's about the best I can do. Alright, so here I'm looking at the output of the current measurement amplifier. I can adjust the common mode and get that down to 0. And actually that's only with the back end being adjusted. The front end, the knob on the front end doesn't seem to be doing much of anything at all. So I guess this shows just how much, or rather how little, I've used inamps. So I made a pretty big mistake when I was designing this. I assumed that a imbalance in these two resistors would would cause a poor common mode rejection, but that's actually not the case. It actually turns out that that these resistors don't actually matter at all when determining the common mode rejection. So let's assume we have this input stage here, and both the inputs are tied together and have some common mode voltage applied to it. We know that the minus inputs are going to be at the same voltage as the plus inputs because of negative feedback and op-amp action. So both of these minus inputs are going to be at the common mode voltage, which means that both ends of this gain resistor are going to be at the common mode voltage. So both ends are at the same voltage, so no current's going to flow through it. So we have no feedback current flowing through this whole chain of resistors. And so if there's no feedback current flowing through this, then no voltage drop, and the exact values of these resistors doesn't matter at all. So that's why that extra pot that I added on the input stage of the inamp wasn't changing the common mode at all, because it literally does nothing, at least for common mode. It does actually change the differential mode gain. So I had assumed that an imbalance in these two resistors would cause one half to have a higher gain than the other half, and that's true, it will do that, but it doesn't actually do anything to the common mode. Since we just take one end and subtract it from the other end to get the final voltage, all it does is end up changing the differential mode voltage by a little bit, by the difference in the resistors divided by that gain resistor. And it looks like that other potentiometer was just stuck. After wiggling it around a bit and sort of breaking it loose, I can adjust the common mode. So now I have a more or less working prototype for my input port for the analog measurement box. I'm not going to bother taking these off of this one because it still works. They're not hurting anything, but I'm going to leave these pots off of any future ones that I build because they don't do anything either. So I just need to build and test a couple more of these and then plug them into an Arduino and start writing some software for it. So that'll be the next video.